Okay, and I'm gonna introduce our speakers. But first, hello everyone again, and welcome to this month's Sustainable Kidney Care Network session. Thank you all for joining us again, wherever you are connecting from, to keep moving forward together in our shared mission of making kidney care more sustainable. Today, we turn our focus to peritoneal dialysis, a treatment often considered more environmentally friendly, but how sustainable it is, really. To answer that, we have two complementary talks today that bring data, real-world interventions, and inspiring next steps from EU-funded Kidney Care project. We'll first hear from James Larkin, a design lead sustainability researcher and PhD candidate at Trinity College Dublin, working at the intersection of healthcare systems thinking and environmental analysis. With a background in product design and technology, James has led the development of one of the most comprehensive life cycle assessment of PD to date. His research focuses on identifying environmental hotspots and practical interventions to reduce the footprint of kidney care. And then we will move from data to practice with Dr. Marina González de Rivera, is a nephrologist at Fundación Jiménez Díaz, Madrid, where she leads the peritoneal dialysis program. Marina has been a co-contributor to the Kidney Care project, helping the development to develop the PD-LCL model and coordinating sustainability interventions within her unit. Clinically, she also promotes incremental dialysis and conservative management strategies to personalize care while reducing environmental impact. And also we'll have Dra. Blanca Tarragón. She's also a nephrologist and clinical researcher, also at Fundación Jiménez Díaz, and she trained at the Glomerular Center of Columbia University and now supports hospital-wide strategies for greener kidney care. Blanca plays a key role in implementing sustainable nephrology practices in PD and beyond, including collaborations with manufacturers, process optimization, and integration of environmental considerations into broader quality improvement frameworks. So those Marina and Blanca will share what their team has already implemented to greener PD and what is next on the roadmap. So whether you're a clinician, a researcher, a policymaker, or sustainability advocate, this session is for you. So James, when you want.
Perfect, thank you, Marcia. Can you see my screen?
Yes, we can see your screen.
Perfect, okay, perfect, thank you.
Yes.
Perfect, okay. Thank you, Marcia, for the introduction. So good afternoon, everyone. So my name is James Larkin, and I'm a PhD researcher from Trinity College, Dublin, currently working on the Kidney Care project. So today I'll be presenting our recent research on mapping the environmental impacts of peritoneal dialysis, or PD as I'll refer to it throughout this presentation, using life cycle assessment. So why does it matter? So let's start with why this work is necessary. So over 850 million people globally live with kidney disease. Dialysis is a life-sustaining treatment, but it's incredibly resource intensive. It relies heavily on energy, water, plastics, transport, and generates large amounts of waste. Healthcare itself is responsible for about 5% of global carbon emissions. So understanding and reducing the footprint of treatment models like dialysis is a key step towards more sustainable care. PD is often seen as the more sustainable dialysis option, mainly because it's done at home and avoids hospital energy demands. But our assumptions can be misleading. Our study asks, how sustainable is PD really when you look at the full pathway? We answer this through a high-resolution LCA, or life cycle assessment of PD treatment, examining all activities and materials used for one patient over 1 year. We had 4 aims for the study: to map the full PD pathway using LCA or life cycle assessment, identify the environmental hotspots, focus on carbon, water, and material impacts, and using the functional unit of one patient treated with PD over 1 year. So looking at the study context, this study was carried out at the AOU Policlinico di Modena hospital in Italy between April and July 2024. I think someone's mic is on. Oh, that's it. It's part of an EU-funded, part of the EU-funded project Kidney Care, and it complies with ISO 1404 and 44 LCA standards. And some of you may know this as the more common environmental standards used in engineering. We included both APD, which is automated peritoneal dialysis, and CAPD, which is manual dialysis approach. So why did we choose Modena? We selected Modena because of its well-established PD program, committed clinical team, and access to detailed product and waste data. Modena is also part of the consortium that we're part of for Kidney Care. It's one of the 4 clinical sites alongside Utrecht, Warsaw, and Madrid. Collaborating with staff allowed us to map procedures in depth and validate assumptions for both clinical and home-based care. So, what is life cycle assessment? For those unfamiliar, life cycle assessment, or LCA, evaluates the environmental impact of a product or system from cradle to grave. That includes raw material extraction, manufacturing and transport, use, and disposal. It's a powerful tool for identifying hidden environmental burdens and prioritizing improvements. So that's just kind of, again, more about that. Here we go. In our case, we used LCA to analyze every component of PD care: the materials used, energy consumed, transport distances, and the waste generated. I'll just go back here, sorry. The importance of LCA. So LCA isn't just academic. It provides the evidence needed to make informed decisions about products and system design, comply with environmental regulations, meet sustainability targets, and ultimately provide care that is more environmentally responsible. In regards to LCA, there's also part where we product teardown and weighing of the products. So in every product, or in this case, every PD product, into components. This included fluid bags, tubing, connectors, and packaging. So we identified the materials, mostly PVC, polyethylene, polypropylene, and weighed each item with a precision scale. All of this data was input into OpenLCA to build an accurate model. So what are PD and HD? I'm just going to touch on this briefly just for anyone who mightn't be so sure. But PD is the form of treatment that uses the patient's abdomen lining to filter waste. This is done daily at home, and hemodialysis filters blood through a machine, typically in hospital, about 3 times per week on average. Comparing PD and HD, in terms of waste alone, PD generates roughly 320 kilograms of waste per year, mostly from the dialysate bags that are used, that need to be transported to the home and used. 1 or 2 generally are used every day for APD, and maybe 3 for CAPD. HD generates about 400 kilograms of waste, typically from dialyzers, bloodlines, and concentrates. In regards to Modena, they use a system that creates the dialysate in the hospital, so they don't have to use the big dialysate bags, but other centers would, which would therefore increase their carbon footprint. Waste was just one part of the puzzle, but we obviously had to look deeper and further. So in regards to PD pathway mapping, in total, we mapped 17 different procedures involved in PD. This included education and training, catheter insertion and removal, the hospital visits for like monthly training or monthly examination and training, delivery of supplies to the home, management and return of waste and supplies. So this comprehensive view allowed us to include impacts that are often overlooked in other traditional LCA studies, and I'll go into this in more detail in a bit. So now looking at our system boundaries. Our system boundary included everything from material extraction to end-of-life treatment. That means we captured not just product use, but transport, training, electricity, packaging, and residual waste. Our overall carbon results. So what did we find? Well, we found that APD produces 3,267 kilograms of CO2 per patient per year. CAPD was slightly less at 2,975 kilograms of CO2 per year. While both are lower than hospital-based HD, these are still high figures, especially considering PD's reputation as the greener option. The reasoning even behind APD and CAPD, the difference would be in regards to the energy use from the APD machine, because in APD you have to use a machine for the dialysis, meanwhile CAPD it's just using bags and tubing. So looking at the environmental impact of PD across 15 different environmental impacts, throughout this range, we looked at climate change, water use, human toxicity, purification, ozone depletion. But for today's talk, we're just going to focus on carbon, material use, and water. But you can even see here how the environmental impact has been affected, or how the environmental impacts are affected across the different environmental impacts. You can see here, like energy use is quite high, ecotoxicity, climate change, and they kind of gradually get smaller as the circle goes round. Looking at environmental hotspots, freight transport of dialysate and supplies regarded up to 1,000 kilograms of CO2 on average between both APD and CAPD. Electricity for the APD machine had around 350 kilograms CO2 of an impact. Plastics was between 275 to 310 kilograms of CO2 between both treatments, and patient and staff travel was approximately 311 kilograms of CO2 across the two. They would have similar patient and staff travel equivalents. Looking at PD procurement, the 5-liter dialysate bag, which is used in APD, had the highest footprint. Transport and plastic production were the dominant contributors, as you can see in this chart. This helps identify where we can act first. Looking at the waste analysis, waste was very significant. CAPD waste was about 320 kilograms of year in weight, with an impact of 810 kilograms of CO2 equivalent. APD waste had a lower weight at 145 kilograms per year, as they use less bags and tubing because they have the machine. So this in turn released around 374 kilograms of CO2 per year. However, recycling was minimal, as most plastic is identified as clinical waste, like the tubings and the certain bags that are connected to the patient, etc., even if it could have been technically recyclable. In regards to electricity use, in regards to the electricity use, I think this is wrong, but most patients use APD overnight with machines plugged in, so that's about 8 to 10 hours of electricity use per night. And the energy use does depend on the national grid mix. Italy uses a fair amount of renewables, which helps reduce the impact compared to coal-reliant countries. Looking at procurement again, we're reinforcing the message that procurement emissions are driven by the weight, volume, and material of items and the distance they traveled. There's clear opportunity here for product innovation and supply chain optimization. We then looked at different studies. So this is just an example of one study where we compared with an Australian study done by McAllister and his team last year. So their range between APD was 2,350 to 4,503 kilograms of CO2 per year. This varied very much by region as they took it across the whole country of Australia. And CAPD ranged from 1,455 to 2,716 kilograms of CO2, varied by region also. Our values do fall within this range, but our model includes more pathways and procedures. As you can see here, I've crossed out some of the ones that they maybe didn't look at. The Australian study only includes the treatment, not other high impact procedures like the monthly examination and training, which had significantly high impacts compared to other procedures. Transport distances and electricity sources explain much of the international variation. So what do we know? To summarize, PD still has a significant environmental burden. Procurement is still the biggest hotspot. Plastic, energy, and transport are key contributors. And small changes like switching packaging, using local suppliers, or improving logistics can make a big impact. So I think that's all I have. So thank you so much for letting me speak. I'll pass back over.
Thank you very much, James. I'm not sure your camera agent has mentioned it to me, but your camera seems to be like frozen.
Okay.
But is fine.
Yeah,
It's
I
just...
think you're frozen for me too.
Oh, okay. So I think before we go to the next talk with Marina and Blanca, I would like to ask you, I'm going to share my screening. I like to do these interactive questions. So if you let me share the screen, I'm going to use...
Have I given you back control? I think I've stopped sharing.
Yeah, you have stopped sharing. Perfect. And but we can't see you now, James.
Okay.
That is
Can
fine.
you see me now?
No. But
Okay.
it's fine, James. While you fix it, I'm gonna share the screen. And if you can you see this?
Yep.
So okay. I'm gonna put this big. So you can either scan the QR or go to menti.com and use the code 336910002. And then I will give you just 1 minute maybe to answer which of these sustainable interventions in PD have you already implemented or are you planning to implement? So I'm going to stop sharing this way because I have to go to Menti now and present. And let's see if we can see people beginning to answer. I'm not sure if you have been able. Can anybody tell me if it works? Does it work? Okay, it seems that it's working. One person has been able to answer. Just one person using sustainable interventions in PD. Okay, I will give you another minute, but I think then Marina and Blanca's talk has quite a lot of sense then, because they will show us all the interventions that they have already implemented or they're planning to increment. I don't know if it's either the QR is not working or the code is not working. Oh, okay, much better. Thank you very much. Thank you. Okay, so if you're using a couple of them, I'm not sure if I've given multiple options, but this is looking quite good. So I think with all these answers that they are, you can, Marina and Blanca, see them. I think we can now switch to your, I'm going to stop
I don't
sharing.
think we can see them, Marta.
Oh, you're not seeing them? Oh, sorry.
No.
Sorry. I thought I was sharing. Now you can share.
There you go.
Sorry, because I stopped sharing one screen and now I'm sharing this one. So this is how it looks. Okay. Going to incremental most of the people and use direct to drain. And in third place, optimization of heating plates, prioritizing CAPD, and then lab test and consumables. So this is looking good. So now I think this links with, I'm gonna now stop sharing. And I think this is linking quite well with Blanca's and Marina's presentation. Thank you very much.
Okay, so first of all, well, can you see my presentation? Okay.
Yes, perfectly.
Yeah. Okay.
Yeah, perfectly.
Great. So first of all, thank you, Marta, again for inviting us to participate in this very interesting and useful talk. After hearing James's wonderful talk all about the carbon footprint of peritoneal dialysis from a more technical point of view, Marina and I are going to talk about our practical way of greening PD at our place of work, which is Fundación Jiménez Díaz in Madrid. Well, you already introduced us, but again, it's Marina and me. We are both nephrologists. She's mainly doing clinical work, and somehow she manages also to collaborate with kidney care. And I, on the other hand, I'm more involved in the clinical research and also doing some nephrology in the clinic. So as the title said, we will be sharing about what we've done in a very practical way. Talking about real world interventions that we have already implemented in our unit. And we will also be sharing about some optimizations that we are currently working on and that will be very soon part of our practice, as well as some potential and almost utopian plans that we would love to see come to life at some point in our careers, maybe. And in contrast with the previous talk, this is not the most technical or super scientific of presentations, but we believe in the power of these types of meetings and sharing real experiences with others to keep learning from one another. Let's start with Marina sharing about what we've done so far.
Okay, I am approaching the initiation of PD treatment with incremental doses offers a number of benefits, including the reduction of plastic and consumable waste. Please note that there is no clear definition of incremental dialysis in PD, which makes it difficult to make a comparative analysis. Published studies differ in their definition, especially in automatic PD. Some studies have defined it as performing APD 5 or less days per week. In our unit, virtually all incident patients start with CAPD modality with one nocturnal exchange and dry day. Those who do not start on incremental dialysis usually come from other renal replacement therapies and therefore require higher doses of dialysis. Those that come from hemodialysis or transplant with lower EGFR rate. In 2024, we conducted a quality of life study, and 50% of our prevalent patients were on incremental dialysis. So as we said, we start out with only one exchange at night. When it is necessary to increase the dialysis schedule, we can continue with CAPD with a higher dose, but most of our patients prefer to keep an overnight PD schedule, which is more compatible with their daily lives. And so we switch to APD if they prefer. The way in which we try to maintain incremental dosing in APD are as follows. We always prioritize using as few bags as possible. For example, we try to maintain a single 5-liter bag in APD at the beginning, adjusting the infusion volume to the intraperitoneal pressure, which also facilitates the storage of material for the patient and reduce the amount of waste. In addition, it makes it easier for the patient to travel. And when possible, we give the patient 1 day of rest per week. We know about prioritized CAPD versus APD. We know, as James explained to us, that the carbon footprint of APD is higher than CAPD. So prioritizing CAPD whenever possible is something we always have in mind. As we just said, 100% of patients start with CAPD to learn the technique and to start incrementally. Afterwards, it is adjusted according to the patient's preference. The subsequent choice of modality depends mainly on the patient's lifestyle, preferring the one that least affects daily activities, but also on the characteristic of the peritoneal membrane, residual kidney function, adequacy of dialysis, and the presence of abdominal wall problems. In our unit, 2/3 of the patients are on CAPD and 1/3 on APD. Again, one of the main contributors to this is our high prevalence of patients in incremental dialysis. Optimization of heating plate use. There is a general consensus that PD fluid should be warmed up to body temperature before infusion in order to prevent patient discomfort whenever possible. This is achieved through warming or heating systems, such as warming plates or warming cabinets. In our PD unit, we have 4 heating plates, and we recently received the approval from our local ethics committee for implementing and analyzing a protocol to optimize their use. We will compare the way we used to do things, which is having all 4 plates at all times in order to always be ready for a potential use, versus the optimized way we recently implement, which is using them only on demand. This requires a slightly level of organization, also nothing major. We had a protocol debriefing and took feedback from the PD staff to assess potential pitfalls or obstacles and adjusted the protocol accordingly. The staff keeps an update visit calendar that they checked every day, and they turn on the heating plates 2 hours before the estimated time of use. This is done if and when possible, since it is not uncommon to have unscheduled patients. However, in our experience, urgent PD exchanges are very infrequent, and we usually are able to wait a couple of hours for the fluid to warm up. In any case, we have not observed great discomfort in the few situations where we have administered the fluid at room temperature. We are measuring the energy consumption with this little device called the watt meter, which allows us to easily monitor the daily electricity use. We will use these measurements to calculate the environmental and economical impact. This is not a revolutionary optimization, but it is really easy to implement and has a potentially substantial impact. So direct-to-drain system. There are direct-to-drain systems like the one mentioned in this study that have shown some subjective benefits among users, like a shorter setup and clearing time. And what's more interesting for us, the elimination of the need to outflow drainage bags. The main associated risk to this system is that it is not possible to observe the effluent properly and detect possible peritonitis in time. Also, in this particular study, they did not observe an increase in incidence of peritonitis. In our practice, we use the Fresenius system for cyclers for historical reasons. Now we do not have Bantif cyclers, but we are considering them in the future. We offer to our patient this Fresenius bagless drainage system, which consists of a long line that drains directly into the toilet. I don't know if you can see the video.
Yeah, I think
Yeah, no?
yeah, it played well.
Okay. 2 years ago, the PD team was changed, and the nephrologists and the nurses, and we took this opportunity to review all our protocols, taking into consideration guidelines by the ISPD, National Nephrology Nursing Society, and our clinical practice. And excessive use of consumables was detected in 2 areas of our care: the protocol of administering intraperitoneal medication and the exit site care. So one of the IP medications very frequently used is heparin. In the past, we used 1 syringe and 2 needles, one for drawing the heparin and a different one to infuse it. This is the left situation. We now use the same needle for both purposes. Yeah, the same one. So in the case of antibiotics, they require to be diluted first, which involves infusing normal saline and shaking the container. We used to use 1 syringe and needle for the infusion of normal saline, then discard that syringe and needle, and then proceed to the drawing and infusion as with the heparin. But we now only use a single syringe and needle for the whole procedure, and have not observed an increase in the rate of infection comparing with the previous years. And moreover, we used to have more accidental stabbings that we don't now. We also reduced the use of consumables involved in the exit site care. We used to recommend to always have the exit site dressed with daily change of dressing, so 1 dressing per patient a day. But now, aligned with the recommendations by the ISPD guidelines, if the exit site has healed, is dry and looking healthy, patients are told not to cover it every day.
There are some other practices that are not necessarily PD related or PD exclusive, but that we do have or are implementing in our clinic. The ones that we already use in our practice are digitalization. We like to call this a paperless hospital, and the use of telemedicine. So Fundación Jiménez Díaz, as I'm saying, is a highly digitalized hospital. In our patient care, we do not use paper for informed consents, but instead they can be signed by patients using pads, tablets, or even our own phones. And we also don't use paper for any of the clinic notes or labs or imaging results, which patients can access through this portal online. The staff also has very limited access to paper. They actually retrieved most of the printers in our rooms. We are left with only 1 printer per department. We also have a very restricted paper supply that comes in monthly. And so most logs and working sheets are digital. So even if we want to print something for our personal use, we really cannot do it. Another great way to reduce our carbon footprint is avoiding in-hospital visits with telemedicine, which eliminates the time and the resources needed for their commute. We usually do visits over the phone whenever we just need to communicate maybe a pending lab result. And in PD especially, the team often uses this tool here that you can see on the right, that is included in the patient online portal, and this is the online dialogue. So as many of you know and experience, the clinicians here and nurses, these PD patients really need a very close relationship and communication with their PD staff, nurses and doctors. And so we encourage our patients to use this chat for frequent questions and for communicating maybe symptoms or signs that could be assessed over this tool, that could be minor complications and can be handled as an outpatient, like maybe a slow outflow, fluid overload management, monitoring of blood pressure and drugs. So this is a way that we have to educate the patient and potentially get rid of avoidable hospital visits. This is obviously harder to do with many of our older patients, but we always try to involve younger or more tech-savvy members of their families to be able to provide them with this fast and easy access to our professionals. So these are the practices already in place in our department. And now we can move on to talk about some of the upcoming and potential optimizations. Continuing with other general practices that are not PD exclusive, we are now working on the reduction of unnecessary laboratory tests in PD. There have been studies suggesting that routine laboratory testing among patients in hemodialysis may be excessive, and that a more tailored and reduced approach can still be aligned with guidelines without compromising patient outcomes. So this is also one of the optimizations we are currently working on as a sub-study for the Kidney Care project, and hopefully we will be implementing it very soon. We see our PD patients every 2 months with a pre-specified set of lab orders, and we thought that maybe some of these analyses were not necessary for each and every one of the visits. So we reviewed clinical guidelines addressing the monitoring of these parameters, and we formed a committee to issue an expert opinion on the cuts that we should be able to make without compromising our patient care. So we will be moving on from our current scenario, which is this, where we analyze all of these parameters here every 2 months, to only keeping the ones that you can see here in darker green, and the ones in light green will be ordered only every 4 or 6 months, depending on which one. But doing this manually, reviewing what should be ordered on each visit and actually ordering it, clicking it in, all the items, would be a near impossible task and really definitely too much to ask to our staff. So the reason we were able to propose this protocol is because we have a great facilitator, which is our IT department. They are involved in many sustainability projects across the hospital, and they were already working on adjusting lab orders and profiles for other areas and departments. So thanks to them, we will have new profiles that we can easily click and order for our patients. We also are working on more sustainable commuting for our staff. We conducted staff surveys on means of transport used for their commute, and to our very positive surprise, only 13% used private transport. However, the sample was only a small portion of the whole nephrology staff, and we are planning on broadening that sample. And when summer is over and everybody is back to work, we are planning on having a meeting to share these results and to try to propose alternative for those who are using private transport, like maybe a carpooling list. Moving on to potential optimizations that are not in our immediate agenda, but we want to talk about working with manufacturers and providers. So local manufacture and shipping is a big factor in the carbon footprint, as James has very well shown. We have talked with our providers, and some of the PD materials come from national manufacturers and others from international ones. For example, Fresenius providers source some of their consumables, such as gauze, as well as some of the machinery, like heaters, from local manufacturers. However, PD fluid bags, drainage bags, and APD machines all come from Germany. Apart from manufacturing, distribution is another important factor in the transportation footprint. For example, Ventiv has a centralized warehouse in Spain, which is in Valencia, which is roughly 350 kilometers away from Madrid. Bulk procurement is another key point where we can reduce carbon footprint associated with transport. Our local Fresenius providers always offer patients to ship a month worth of products, but one big limitation is that some of our patients don't have the room for it at home, and they have to increase their delivery frequency accordingly. Taking back and recycling PD products is something that we have asked our providers to do many, many times, especially with patients that transfer to hemodialysis or that get a transplant and no longer need the PD equipment and consumables that they keep at home. But unfortunately, they are not allowed to do so due to healthcare product regulations. And we would love to hear if this is not the case in any of your practices, please. We'd be very happy to hear so. And lastly, some innovative technologies that could contribute greatly to our PD sustainability are also somewhere in our horizon, but we don't really see a way to implement them right this moment. Renewable energy options would be a great way for all of our patients with home techniques. In Madrid, at least, I don't know about other regions in Spain, but in here, at least, there are no special subsidies for people in this situation, particularly. Although our patients, as well as any other person in a region, can ask for them. We should work maybe on encouraging our patients to do so, but unfortunately, this is somehow out of our expertise, and there is a lot of paperwork involved, and we currently are unable to offer them real help with this. Another innovative technology that would significantly reduce patient transport use is home-based blood testing. This is another optimization that we currently don't have access to, but we would be very happy to hear your experience if you do. And so to wrap this up, we have already mentioned the barriers and challenges we face in our clinical practice with all of these optimizations. As doctors and nurses, here is a slide to summarize them all in order of increasing magnitude in which they are somehow out of our hands or harder to do from our end. So starting with something that is purely in our control is, as we mentioned, old school practice. We mentioned that it took a change in the PD staff in order to rethink and update our practices. It is vital, as it is in all of clinical practice, really, to stay updated and to participate in sharing meetings like this one. And that way we will guarantee not only the best clinical practice for our patients, but also the most sustainable one. The next one would be time. We know that this is always an issue. It is a big challenge already in our clinical practice, explaining some of these options that we've talked about today, some of the practices and implications of the techniques that our patients carry out at home, in addition to the already restricted visit times that we have, makes our practice even more challenging. Working with other departments is sort of a double-edged sword. For sure, cooperating with others, as we mentioned with our IT department, helps us achieve our goals. But especially if they are not physically close to you, it always comes with communication troubles, and things and changes just take longer. Working with suppliers and manufacturers holds a very high potential impact, but it is hard to move the big corporate machine from our humble little practices, really. And finally, regulatory bodies, as we have mentioned, also play a part in impeding some of the things that we would like to do. It goes really without saying that changing regulation takes up an enormous amount of time, knowledge, effort, people, and so it is easy to just give up or even not try. But however many obstacles we may encounter, we would love to continue on this path with all of you towards a greener future in PD and kidney care in general, even if that means just taking the smallest steps at a time. Thank you very much for listening, everybody.
Thank you very, very much, Blanca, Marina, and James. And now I would like to see, I don't see everybody, but is there any questions from the people listening? Okay, Gareth?
Hi, good afternoon. Really interesting, although as a renal tech, I'm far more hemodialysis based. What I have come to realise, and if you're aiming high, then at the end of the day, PD fluid is just salty water double wrapped in plastic and driven thousands of miles. All of the technology exists to make this in situ. whether it be tiny little RO membranes, whether it be tiny little ultrafilters. So the way that PD will fundamentally change is when we can make it from tap water and then just put it down the drain afterwards. So I just encourage the PD community. I believe one manufacturer has been attempting to do it. But this is true. We're looking at doing it with our CVVH treatments in ICU. Anywhere we buy salty water, we have the technology now just to make that in situ on a as required basis, and that would fundamentally change everything, I think. So everybody in PD, please press for that with your manufacturers.
Absolutely, we totally agree. Thank you for your contribution. Yes.
Yeah, well, just for you to know, Gareth has just published an article in Central Acid Delivery in Hemodialysis, so he knows very well what he talks about. And thanks to this European project, Gareth, let's see if in the Work Package 4 that is related with innovations, we get closer to the comment that you have just made. I know they are already trying to work on that. So let's see if in not many years' time, we can see something closer to what you have mentioned. So any other questions from you, Andrea?
Marta, I want to comment that I think there is a study that Madrid, I think La Paz is participating, that they are investigating how to reuse the effluent, like to when the patients finish the dialysis, like the effluent could be cleaned at home, like to get some clean fluid again, and to that not to need all of the bags every day, no, a new liquid and a new bag, but it's very insipid. I don't know how to say it.
Preliminary. They haven't published their results yet.
No, they are. The study is ongoing, but it's like very few patients.
Oh, okay. Well, we will keep the track of the Spanish study, and we will follow it in our and whatever update that I get, I will try to put it in the network. Okay. So, Andrea, no?
Yes. Hello, everybody. I would like to ask James, which was the method or technique did you use to identify the components of the materials?
Perfect. So what we did was when we were weighing and dismantling the products, we used to first kind of check the packaging. Or can you guys hear me okay, actually?
Yes.
Perfect. Yeah, we can hear you.
Perfect.
I think who is sharing the screen? Okay.
Okay.
It was me.
Well, we can't see you, James.
Yeah,
we can hear you.
I can try again, but my camera's. Can you see me now?
No, but it's fine. It's fine. Just
Okay, sorry. I'm in the office, so I think the internet's not good. But we would look at the packaging, and from that you could kind of gather where the transport where the products were manufactured, and then we would look at safety data sheets or instruction manuals, which sometimes come with the products, or sometimes we would find online, and we gathered a lot of information this way. And then our other options were to phone the companies or message the companies and gather information from this. And then there are some OpenLCA assumption data lists which we used too, if we really couldn't find something, or if it got really difficult, it was down to probably an assumption or like from a similar product that we could get information on. But for the most part, we were able to find most of the data through looking through safety data sheets and instruction manuals, etc.
Okay, thank you.
I can't see any other hands for the moment, but while any other one want to ask anything else, I will ask to James. You have mentioned in your talk regional differences, like, and because your study was performed in Modena, but you have also compared your results to the Australian study. So how do you think these regional differences will influence the environmental impact of PD, and how might this will affect generalizing the results and your recommendations?
Perfect. So I suppose, like, as I kind of said earlier on, like even the energy grid mix, like that would be different across different regions, like the amount of like renewable energy certain countries have, or whether they're more reliant on coal, etc. I'm looking at transport logistics. Like if a manufacturer is based in Ireland, for example, obviously if they're transporting goods around Ireland or to the UK even, it's going to be a lot, their transport is going to be a lot lower than if they were having to transport maybe further around Europe, like Greece or Cyprus, etc. Waste management also differs by region. Some countries incinerate more, some countries recycle more, but the hotspots are consistent in regards to the hotspots are consistent in regards to like plastic freight and electricity. So while like the numbers may vary, like it's still very much transferable across Europe, this data and results.
Okay, and based in looking at your results that you have when you compare APD and CAPD, it's quite curious that knowing that electricity consumption is much more in APD. I don't know if I've seen it properly, but it looks like waste is less in APD in comparison with, say, CAPD.
Yeah.
Can you explain it a bit better, because the bags are
Wait,
bigger?
waste is less in APD. Yeah, that's because in CAPD they use more products to move the dialysate as it goes into the abdomen without the use of the machine. So I suppose in that sense there are more products used, which is why the waste is like more waste from CAPD than APD.
Okay.
I think, Marta, that one contributor could be that, for example, in CAPD, you have to use 3 taps. For example, if the patient has 3 bags per day or 4, you have to use three taps. With iodine, yeah.
Thank you, Blanca.
Or 3 heparins. For example, if the patient is with heparin, in APD, you just have to use 1 or 2. Maybe it's why they have more waste.
Perfect. I don't know if there is any other questions from the public, but if not, I will continue asking Blanca and Marina. You have talked about all these interventions that you have already implemented and the ones yet to be implemented. Can you tell us which one do you think from the ones that you have implemented that is going to have more impact environmentally talking, or from those that you have already been implemented, implemented, or yet to be?
I think that the incremental
dialysis, I think is the most important optimization, because the difference is very, very high, even in APD, incremental APD. I think someone comment on chat that there are few patients that can be only with 1 bag, and also the weight of the bag for all patients is 5 kilograms. So it's true that not all patients can have this technique, but reducing the volume of every cycle in the machines is very useful to not only for the environmental impact, but also the patients are very grateful with you, because when they travel, they just have to carry when they carry the material just 1 bag per day. And I think maybe not for a long time, but like for the first 6 months, it reduced a lot the consumptions, the consumables, So this, I think this is the most important. Also the for example, the exit care,
The
the
dressing.
exercise,
Yeah.
dressing. This is something that I learned from China because I had a patient that came from China, and it was the first time that I saw an exit site without covering, without a cover. So this made me think that maybe we were using the dress without needing it. So we reviewed the guidelines, and maybe if the exit site is completely clean and completely dry, it's not make a difference, and you reduce, because it's one dress every day, every patient, maybe 365 days. So this is also very impactful. Yeah. What else? The analytic.
Sorry, Blanca.
No, I was going to say that in terms of maybe the effort, the ratio of effort to, benefits, like the electricity use is really easy to manage and to reduce if you just spot the thing that you need to change, and it really doesn't have that much of an impact.
Yeah.
So yeah, just checking your daily practice and the machines that you use can be just a 1-day effort, and then you can change your practice in a very significant way.
That goes a tiny bit with my next question, that it was going to be, which one do you think from the next steps that is going to cost you more effort, find more resistance between your colleagues? Because we can see that you are very motivated, but you are not alone in this PD team. So which one do you think is going to cost
I think
more
convincing
effort?
the staff to change their transport
Yeah.
might be challenging, because, well, life is life and not everybody can do those adjustments. So convincing a person to change their daily use of their car might be too big of a challenge, but we will definitely try.
Yeah. Even in Madrid, we have it very easy because we have a very good public transport. So I think that's why we have a high percentage of staff that comes in public transport. But so the few people that's come in private car is because they live
far away. Yeah, they are not very well connected.
Yeah, but this would translate also to patients, but again, it's hard to convince people to, change their habits, and maybe older people or people with disabilities need their private transport. But yeah, we can make the effort.
I like linking with this. I like the comment of Caroline Stigant saying that unfortunately she had to leave us, but she had to hop on her bike to work soon. So that's linking very well with you. So Gareth, again, I think we have time for the last question.
Yeah, very quickly. We put people off in London, especially by having sky-high parking charges, and even permits for the hospitals are almost impossible to come by. The one note of caution I add, and I say this to a lot of people, is data storage is not a free lunch. The data storage is now a bigger emitter than the airline industry. And James, obviously from Ireland, I saw a report the other week saying over 20% of Ireland's entire electricity production now goes to data storage centres. In the UK, it's about 4.5% or something. So removing paper sounds great, but if we replace it with huge amounts of data, that could end up being counterproductive. That's all. Thank you.
Yeah, we will have to find the balance, Gareth, between storage and not using paper. I'm not sure if Frances would like to add something else, or if not, we will leave it here because it's 3 o'clock. So I think it's been an amazing session altogether. So I would really like to thank the three speakers for the very wonderful talks. And I think they've been very, very helpful. As I said at the beginning, this is being recorded. So I will try to place the recording as soon as I can for those who haven't been able to be here with us today. So thank you very much to everybody. And I think our next one will be in September with reducing water in hemodialysis. Okay. So thank you very much, everybody,
Thank you.
for being
Bye.
here.
Thank you, Marta. Thank
Bye.
you, everyone. Bye.
Bye.
Thank you.